Okay, so we'll discuss questions based on ideals. ठीक है, we have taken some questions on ideals and principal ideals. Some more good questions in fact. अच्छा, इससे पहले एक चीज़ है, so let us discuss that first. Division ring क्या होती है, वो सब तो we already discussed. So there is a thing known as simple ring. ठीक है, simple ring. ये एक concept है. ठीक है. If a ring R has only 0 and R itself is its ideals, then this ring R is said to be simple ring, provided there exist two elements, let's say A and B in R such that A dot B is not 0. Okay, so this is the definition of simple ring. So there are two things which needs to be satisfied by a ring, then we'll say that that ring is simple ring. First thing, that there should exist two element in the ring, at least two element in the ring, such that their product is non-zero, and this ring should have only this null ideal and R itself is its only ideal. कहने का मतलब ये हुआ that this ring should not have proper ideal. ठीक है, simple ring has no proper ideals. ठीक है, proper ideals means other than 0 and R, जो ideal होंगे, those are known as proper ideals. Okay, so this is the definition of simple ring. Based on this, we'll try some questions. In fact, some questions won't mention simple ring, but they will use these properties. Like if in a question it is given that there is a ring which has only improper ideals or which has no proper ideals, ठीक है, and then some question will be asked. So basically indirectly they are asking on simple ring only, right? So okay, we'll discuss questions on this concept. उससे पहले let us take some questions which some of which are based on simple ideal concept, and then they will use this simple ring concept as well. ठीक है. So okay, check whether I, which is defined as a matrix of 2 cross 2 order, जिसके की elements are integers. ठीक है. So we have to show that check whether this is an ideal or not of 2 cross 2 matrices or integers. ठीक है. Okay. तो देखो क्वेश्चन 1 जो है उसका सॉल्यूशन देखा जाए तो क्या है, हमें I जो है वो डिफाइन है इस टाइप से कि x y 0 0 such that x y are integers. ठीक है. Of course this is subset of जो m 2 cross 2 matrices डिफाइंड है जिसका कि every element will be integers. तो ये क्या है, these are nothing but let's say A B C D, where A B C D are integers. Okay, so this is subset of this. Basically C and D has been taken 0 here. So this is a subset of M2 cross 2 matrices, which are nothing but 2 cross 2 matrices whose elements are integers, right? So now we have to show that check in fact whether this is an ideal or not. ठीक है. So ideal के लिए पहली चीज तो first thing we can say that I is in fact subset of M2 cross 2. Further 0 0 0, this pertains to I. That means I is non-empty, which we can say by 0 0 are also integers, so they are part of this. So this won't be I want to be empty set, this is non-empty set. So these two things we have done. Now the real properties we need to satisfy. So first thing, that if we take let x1 y1 0 0 and x2 y2 0 0, this belongs to I. Then if we see that this is our let's say this is element A and this is element B, so we are seeing A minus B now. So minus x2 y2 0 0. So this is by subtraction of matrices we can say that this will be nothing but x1 minus x2, y1 minus y2, and 0 minus 0 is 0 0. Okay. So this is of course in I, because this is the format of I, right? There will be integers x and y, and then these two basically the second row both elements should be 0, and first row both element can be 0 as well as non-zero. The necessary condition is that second row must be 0. So that is being satisfied. I mean this lie in I. Now second condition क्या है? Now for let us say जो हम small r लेते थे वो let us take from that we have to take from M to cross to matrices. So let us take this A B C D. ठीक है, और यहाँ से जो एलिमेंट लेंगे A वो हम x y 0 0 ले लेंगे. ठीक है, अब देखो इफ वी सी आर ए तो ये क्या आएगा A B C D and this is x y 0 0. So this will be a matrix multiplication. So ax plus 0 and ay plus b into 0 is that is 0 only, cx plus d0 and this is cy d0. ये हो गया which doesn't pertains to I of course, because for I this element will be in I only when the second row is 0, which may not be 0 here. If c and x both are not 0, then this won't be 0. ठीक है, so in fact this is not an ideal. Thus I is not an ideal in M2 cross 2 matrices over integers. ठीक है, अच्छा इसमें रिलेटेड क्वेश्चन ये भी हो सकता है कि क्या इससे तो वी कैन से दैट दिस इज नॉट, यहाँ से व्हाट वी कैन से दिस इज नॉट लेफ्ट आइडियल. ठीक है, इन पर्टिकुलर नॉट लेफ्ट आइडियल. आइडियल तो होगा ही नहीं. इफ आइडियल होने के लिए तो लेफ्ट एंड राइट दोनों सेट्स पे होनी चाहिए. बट अगर सिंपली पूछा जाए कि विल इट बी लेफ्ट आइडियल, देन दिस वोंट इवन बी अ लेफ्ट आइडियल, बट विल दिस बी राइट आइडियल? सो लेट्स चेक फॉर दैट. राइट आइडियल होगा क्या ये? अगर राइट आइडियल की बात करें तो बेसिकली पहले विल टेक द एलिमेंट ऑफ I which is x y 0 0, and in the right side we'll take element of capital R which is A B C D, because now the element of R are absorbed from the right side, then we say that that is a right ideal. So अगर इसमें वही apply करें, so this will be x A plus y C and then this x B plus y D, and then this is 0 0 0 से multiply करेंगे तो 0 है. This is of course in I because second row is 0. So I is absorbing element of R from right side, so this is right ideal. I is right ideal. ठीक है, so the question may ask that show that this is an right ideal, then yeah this is an right ideal. Further question may say that will this be left ideal as well, then this is not left ideal. If simply ask will this be ideal, then of course it won't be because this is not left ideal. So how can it be an ideal? Ideal means two-sided ideal. ठीक है, so I hope समझ में आता है. So this was simple yet a good question. ठीक है, सिंपल एप्लीकेशन की अगर ये समझ में आता है तो ये समझ में आ जाएगा कि आइडियल क्या चीज़ है. ठीक है, so now let's see next question. Yeah, this is done. Show that for a field F its only ideals are 0 and F itself, i.e. a field has no proper ideal. Okay, so this is simple. A field has no proper ideal. This is the question. We can say the show that. This is question 2. ठीक है, so this is simple. I have discussed in previous lecture that that AR is in fact ideal of AR is ideal of a commutative ring commutative ring R. This I have shown in the previous lecture. If question comes in the exam, then we need to show this as well, that AR is an ideal. Okay, we know that AR will be defined as AR where R belongs to R and A is a fixed element of R. Then we show that this is an ideal, वही non-empty होगा, and those two properties A minus B will be in AR, and for a given element R, R1, AR and AR from A capital R, the closure property will be satisfied in this. ठीक है? So that I have shown in previous lecture, so you may refer that. So this will be an ideal. ठीक है? अब देखो, अब previous lecture में एक चीज और बताई थी मैंने, that if one belongs to ideal of if one belongs to an ideal I, that implies that I is equals to R. That I have shown. ठीक है? If unity is if one unity lies in the ideal, then that ideal has to be equal to R. This is also the question I had discussed in previous lecture, so you may refer that. ठीक है? So these two things will use here. ठीक है? So हमें ये शो करना है कि a field has no proper ideal. Okay? So देखो, केस 1 क्या कर सकते हैं कि I equals to 0 is the ideal of field F. So there is no doubt in that. Null ideal is an ideal. ठीक है? So there is nothing to prove in this. ठीक है? Nothing to prove. ये हो गया केस 2. केस 2 क्या करेंगे कि मान लो I is not 0. ठीक है? I is not 0 means if we take AR is an ideal of R. ठीक है? AR is an ideal of R. Yeah, that we can share, right? अब इसमें देखो A won't be 0. अगर A 0 हो गया इसमें बिकॉज यूनिटी भी है, ऐसा बोल सकते हैं, जो 1 है that pertains to R. अच्छा, फील्ड क्या होता है? फील्ड इज ए कम्यूटेटिव रिंग, a ring with unity, a commutative ring with unity in which non-zero elements has multiplicative inverse. ठीक है? So that's the definition of field. So फील्ड में यूनिटी भी होगी. ठीक है? So 1 belongs to R. ये तो है. इसका मतलब क्या होगा? अगर 1 R में है तो इसमें व्हाट वी कैन से 1 तो R में हो गई, दैट इज गिवन. फर्दर देखो AR जो है दैट वी हैव डिफाइंड एज AR सच दैट R बिलोंग्स टू R. अब इसमें देखो A कैन नॉट बी 0, क्योंकि अगर A 0 कर दिया हमने तो A 0 करते ही तो क्या हो जाएगा? AR 0 ही हो जाएगा. ठीक है? इफ A इज 0, भाई 0 से मल्टीप्लाई करेंगे किसी भी एलिमेंट के R को, विल गेट 0 only. So A not equals to 0 is the precondition in fact, because case 1 we have taken 0 case. ठीक है? So A is not 0. Further 1 belongs to R. So A into 1 that is equals to A. This we can say by the multiplicative property in, or by the, because unity exists in R, so this property is satisfied. So this belongs to AR. आई होप क्लियर है. ये कैसे हो गया? देखो AR कैसे डिफाइन है? दिस इज डिफाइंड एज A डॉट R. अब जो R है वो कैपिटल R का एलिमेंट है, बट R जो है 1 भी हो सकता है, बिकॉज यूनिटी इज आल्सो देयर. सो जब यहाँ पे R 1 होगा उस टाइम A जो एलिमेंट है वो AR का ही पार्ट होगा. सो A परटेन्स टू AR. ठीक है? फर्दर इट इज नोन कि A जो है 0 नहीं है. A इज नॉट 0 बिकॉज A परटेन्स टू AR. दैट इम्प्लाइज दैट A जो होगा वो R में भी होगा, बिकॉज A जो है, A तो इनफैक्ट सबसेट है कैपिटल R का, AR तो कैपिटल AR का सबसेट है. AR is in fact ideal. So A pertains to R. This means A inverse will be in R as well, because R is a field and A is non-zero element. So all non-zero element of a field have multiplicative inverse. ठीक है? So by property of ideal I for A inverse belongs to R. A inverse, we have seen that this is in R, and A we know that this is in AR. So from that we can say that A inverse dot A जो होगा that will be in A capital R, because that is the condition of that is the definition of ideal in fact. इफ ए जो भी एलिमेंट ए अगर आई से लें और आर जो है कैपिटल आर से लें तो ए आर जो है वो आई में लाई करता है। अब यहाँ पे आई की जगह ए कैपिटल आर है जो आइडियल है हमारा। ओके बट ए जो होगा दिस इज नथिंग बट दिस इज वन ओनली ना, बाय इनवर्स एक्सियोम इन आर, ठीक है। ए एंड ए इनवर्स आर इनवर्स ऑफ ईच अदर, ठीक है। A inverse is nothing but multiplicative inverse of A. So by the definition of inverse we can say that A inverse dot A is 1. So यहाँ से we can say that 1 belongs to A. Further now I will use the second definition, जो second question in fact जो हमने previous lecture में use किया था कि अगर 1 जो है if unity lies in an ideal then that ideal has to be equals to R. So that implies that AR has to be equals to R. AR has to be equals to R, ठीक है। सो इनफैक्ट ये ए आर को अगर अपन ये भी नहीं लेते, कोई भी नॉर्मल आई लेते ना तो भी सेम चीज़ होती। इवन इफ वी हैव टेकन ए रेंडम आई, कोई भी आई ले लेते, ठीक है। सो मान लो ये आर का एक सबसेट ले लिया एंड दिस आई इज नॉन जीरो बिकॉज जीरो केस तो हमने ले लिया पहले ही, ठीक है। इफ दिस इज टेकन एज नॉन, आई एम शोइंग दैट इवन इफ वी डोंट टेक दिस आई एज ए कैपिटल आर देन ऑल्सो दिस विल बी वैलिड। वो जो आई होगा दैट विल ऑल्सो बी इक्वल्स टू कैपिटल आर, ठीक है। जैसे ये हमने ले लिया आई इज नॉट इक्वल्स टू जीरो, दिस वी कैन से, ठीक है। सो देयर विल बी सम एलिमेंट, इन फैक्ट देयर विल बी सम एलिमेंट a not equals to 0 in I, non-zero element will be there in I because this is not 0, तो at least one non-zero element has to be there, otherwise तो ये null ideal हो जाएगा, ठीक है। so this implies that जो A है that belongs to R because I is subset of R. If I is ideal then this will be subset of R, right? So from this we can say that A inverse pertains to R because R is filled. So every non-zero element will have multiplicative inverse in R. अब देखो now by definition of ideal, by definition of ideal, A inverse pertains to R and for A inverse pertains to R and A pertains to I, A inverse dot A which is 1, of course this will pertains to I because that is the definition of ideal. So we can say that as 1 pertains to I, so I has to be equals to R. So the only possibility for ideal is, so only ideals possible for field R, जिसको हमने F बोला है, R F जो भी है, only ideals possible for field R is 0 and R itself. Okay, so hence proved. So the only ideals a field has are 0 and field itself. There are no proper ideals, ठीक है। So ये जो फर्स्ट चीज़ मैंने दिखाई, इनफैक्ट दिस ये अपन डायरेक्ट इससे करेंगे इसको क्वेश्चन को, क्योंकि हमें एक जनरल केस के लिए दिखाना है, ठीक है। ये जो फर्स्ट चीज़ दिखाई मैंने ए कैपिटल आर लेके, दिस विल बी यूजफुल इन अदर क्वेश्चंस बट इन दिस क्वेश्चन ये एक स्पेशल केस हो जाएगा। सो दिस इज नॉट नीडेड इनफैक्ट इन दिस, ठीक है। आई होप ये समझ में आता है। सो ये जो सेकंड पार्ट है दैट इज सफिशिएंट फॉर आंसर टू दिस, दैट a field has proper ideals only, improper ideals only, no proper ideal will be there for a field, ठीक है। now let's see second question. What is second question? Second question is this: show that a field, अच्छा this we have done, no proper ideal of a ring with unity can contain an invertible element. Yes, जो सेम चीज़ है, घुमा घुमा के पूछा जाएगा एक ही क्वेश्चन। ये बहुत यूजफुल है, देखो इसमें आइडियल्स में अगर यूनिटी आइडियल में है तो दैट आइडियल हैज टू बी इक्वल्स टू आर एंड दिस ए कैपिटल आर वाला कॉन्सेप्ट भी विल आल्सो वेरी हैंडी इन मेनी क्वेश्चंस, ठीक है। in some PYQ also there, ठीक है। so now let's see this question, ठीक है। question third: no proper ideal of a ring with unity can contain an invertible element, ठीक है। let I be proper ideal of ring R containing an invertible invertible element A not 0, ठीक है. Let's assume that a proper ideal contains an invertible element, ठीक है. Basically what we are saying that A pertains to I and A is non-zero. If A pertains to I, ठीक है, that means A pertains to R as well because I is ideal, so this will be subset of R, ठीक है. But A is invertible, so there exists A inverse belongs to R such that A inverse dot A equals to 1. This is the definition of invertible element in fact, ठीक है. सो दिस इज ट्रू बिकॉज क्वेश्चन में बोला हुआ है कि अगर आइडियल जो अगर इन्वर्टिबल एलिमेंट आई में है दैट वी हैव एज्यूम, ठीक है. सो देन दिस ए इनवर्स हैज टू बी इन आर. नाउ बाय definition of ideal, for A inverse belongs to R and A belongs to I, A inverse dot A has to be in I. भाई यही तो डेफिनेशन है कि ए आर जो है वाई में होगा, वो आर बिलोंग्स टू कैपिटल आर एंड ए बिलोंग्स टू आई. बट दिस मीन्स वन परटेन्स टू आई. अगर वन आई में है सो आई हैज टू बी इक्वल्स टू आर. दैट क्वेश्चन आई हैव डिस्कस्ड. अगर यूनिटी आइडियल में लाई करती है देन दैट आइडियल आई हैज टू बी इक्वल्स टू आर. ओके, सो आई इज नॉट प्रॉपर आइडियल विच वी एज्यूम्ड, ठीक है. वी हैव टेकन अ रैंडम आइडियल एंड विच कम आउट टू बी आर, ठीक है. other ideal is I equals to 0, ठीक है. but then this won't contain invertible element because only non-zero element can have inverse in a ring, ठीक है. inverse means multiplicative inverse, ठीक है. hence the result I hope समझ में आता है कि if an ideal contains an invertible element then it cannot be proper, it has to be improper, ठीक. so that this is also a good question. basically देखो बार बार यही चीज़ों का यूज होना है. वन pertains to I and this A capital R वाला in some question that will also very handy. okay, so let's see this. okay, division ring is a simple ring, ठीक है. the next question 4. division ring is a simple ring. question 4. division ring is a simple ring. okay, so this is easy. simple ring की definition we have seen. what is the definition of simple ring? simple ring क्या होती है that there exist at least two elements such that there exist at least two element A and B such that AB is not 0, ठीक है. and this ring R has no proper ideals. this is the definition of simple. these are the two conditions, ठीक है. so हमें ये शो करना है कि division ring is a simple ring. so we can show that, ठीक है. division ring means non-zero element will have inverse. non-zero element of division ring non-zero element of division ring is multiplicative inverse. okay, so now we have to show that this ring जो है division ring this has no proper ideals, ठीक है. so case 1 क्या होगा? let I equals to 0, then this will be ideal of a division ring, ठीक है. there is nothing to prove in that, nothing to prove, ठीक है. if जो ideal है वो null ideal है then there is nothing to prove. case 2 I is not 0, ठीक है. other than this So now we have to show that there is no proper ideal. So वही सेम चीज हो जाएगी इसमें भी, ठीक है। अगर I नॉट जीरो है, that means there exists a नॉन जीरो एलिमेंट pertains to I, ठीक है, हैज टू बी। अदरवाइज अगर इसमें सारे एलिमेंट जीरो होते तो फिर या अगर जो आइडियल है वो जीरो होता, नल आइडियल होता, देन देयर वोंट बी एनी basically non-zero element, but here the case 2 is that I is not null ideal, so then there has to be at least one element जो कि नॉन जीरो होगा, ठीक है। दिस implies that this A will be in जो हमारी डिवीजन रिंग में लो उसको R बोल देते हैं, will be in R as well, ठीक है। बट नॉन जीरो एलिमेंट of division ring is multiplicative inverse. So for A belongs to R, there exists A inverse belongs to R such that A inverse dot A or A dot A inverse, which is of course 1, ठीक है। It's the property of multiplicative inverse, right? So, okay, now by definition of ideal, definition same चीज होगी, इनफैक्ट definition of ideal क्या होगा, for A inverse belongs to R and A belongs to I, A inverse dot A which is 1, this will belongs to I, ठीक है। That means I has to be equals to R, because if unity is in ideal then that has to be equals to R, that we have already seen. Hence only ideals of division ring are 0 and R itself, ठीक है। Further there exist A and B in R such that AB not equals to 0. इनफैक्ट क्या करेंगे अपन, तो A नॉन जीरो लिया हमने, वही ले लो दो बार, A डॉट A करेंगे, सो नॉन जीरो आएगा, ठीक है। क्योंकि अगर जीरो हो जाएगा, बिकॉज A एंड जो A स्क्वायर है वो जीरो हो नहीं सकता, बिकॉज मल्टीप्लिकेटिव इनवर्स एग्जिस्ट करता है, सो A इनवर्स करेंगे तो A जीरो हो जाएगा, दैट्स व्हाई A डॉट A वॉन्ट बी जीरो। So these two properties are satisfied, hence this division ring is a simple ring. So division ring is simple ring. Okay, so hence proved. I hope ये समझ में आता है। So this is a good question. In fact देखो बार बार वही चीज़ें यूज हो रही है, ठीक है। So ज़्यादातर क्वेश्चन इसी टाइप करेंगे इसमें।